This video is dedicated to the practice redemption task for outcome 1 for the number patterns and sequences topic, which is chapter 8. There will be 8 questions found within this task. Let's have a look at the first question. The first question, in the sequence 8, 17, 26, 35, 44, the value of the common difference D is what? To get the common difference, we just grab any term, that's not the first term, and subtract the previous term. In this case, we're going to do 17 take away 8. This will give me an answer of 9. Just to make sure that this is the common case, let's take another term, 44, which is the 5th term, and subtract its previous term, 35. Again, this is 9. So our common difference in this case is 9. The next question says a sum of $4,800 is invested in an account that pays 9.7% per annum simple interest. We have to find V0, which is the initial amount, and use this to write a recurrence relation that models the value of the investment after a certain amount of years, which is dictated by n. We know what V of 0 is. V of 0 is the initial amount, and this is generally said within the question. So in this case, V of 0 is 4,800. Any recurrence relation always starts off with V of n plus 1 is equal to V of n. Now either we're going to add or subtract some certain amount. In this case we're going to add because it's an investment, so we're getting more money added into this account. But what we don't know is how much the specific number is. So we have to do a little bit of calculating, and in this case we need to find out what 9.7% of 4,800 is. This is very simple to do. In the ClassPath calculator, keyboard up, fraction, and we're going to do 9.7 over 100, and we're going to multiply this by the initial amount. $465.60. So there is our recurrence relation. All this means is that after a certain amount of years, $465.60 will always be added. And to find that the next value, you just get the previous value and add $465.60, starting with the initial of 4,800. Question 3 says a common ratio R of the sequence 6, 42, 294, and 58 rather is 1. To get the common ratio is kind of the same as getting the common difference. The only thing that's different, because it's a ratio, we're going to be using division. So we'll grab any term, 42, and divide it by its previous term, 6. This will give me 7. Try it again for 294, and divide this by 42. When you put this into your calculator, we should hopefully get 7. In this case, we do. So our common ratio R is equal to 7. Question 4 says, find T of 0 and T of n plus 1 for the sequence 10, 15, 22.5. T of 0 is very simple because it's given to us within the first term, so the initial term. The T of 0 is equal to 10. Our initial is 10. To get T of n plus 1. Now the thing is, we don't know if this is going up by a certain fixed amount or if it's being multiplied by a common ratio. We know it's going up from left to right. So let's have a look at the difference here. From 10 to 15, there's a difference of 5, so we're adding 5. So we're expecting the next number to be 20 if we're going to add 5, but it's 22.5. So we're not necessarily dealing with a common difference, but instead a common ratio. So what I should do is take one of the terms and divide it by its previous term to see what we get. So 15 over 10, this will give me 1.5. And just to double check that this is the case, let's make sure we can do 22.5 over 15, and this should give us 1.5. So our common ratio in this case is 1.5. So to get the next term, we multiply the previous term by 1.5. So 1.5 times t of n. Question 5 says, a herd of bison increases by 11% each year. If there are originally 1,200 bison in the herd, write a recurrence relation for the number of bison b of n plus 1 after n years, making sure you state b of 0. So we're writing recurrence relation. The initial amount of bison, b of 0, is 1,200. Now this is increasing by 11% per year. So we know to get our b of n plus 1, just like the previous question, it's going to be a certain amount that you're going to multiply, which is the common ratio, and you're going to multiply this by the previous amount. Apologies, I have to pause there because my 2-year-old son just walked in and gave me some lovely food of dyed green pasta, some felt, which is a coconut, a wooden egg, a wooden lemon, wooden carrot. Anyways, where were we? Okay, so b of 0 is 1,200. To get the next term, we need to find out what our r value, our common ratio, is. Now, a lot of people would think that this is going to just be 11 times b of n, but this is not the case because this is a percentage. 11 is a percent. But we can't just then put find out what 11% of the 1,200 is, because this is increasing by 11% each year, or in other words, it's a compound. So we need to call an R formula. Because it's growth or increases, this will be 1 plus the rate divided by the amount of compounds p all over 100. We know what our R value is, it's 11. And we know what our P value is. P just means how many compounds happen per year. The question says a herd of bison increases 11% each year. It's only happening once per year, so our P value is 1. And when your P value is 1, you just got to write it as whatever the R value is over 100. If it's maybe half or quarterly, that P value will change to 2 and 4 respectively, but because it's once, we just leave it as 1, and when any number is over 1, we just leave it as that number. So 1 plus 11 over 100, this is 1.11. So we found our R value to be 1.11 multiplied by b of n. Question 6 says the following recurrence relation can be used to model a compound interest investment of $18,000 paying interest at a rate of 3% per annum. This is the model here. K of 0 is 18,000. K of n plus 1 is equal to 1.03 times K of n. And you can see how we got that 1.03 is based on that 3%. You can see some familiarity, there we go, with the previous question. A little bit of a tongue twister. But the question says, after how many years will the value of the investment first exceed $25,000? We're just going to use a calculator for this question because this is the best way to approach this. So in a ClassPad calculator, let's get rid of the keyboard. I'll put this to the side here. The ClassPad calculator, go back to menu, and we're going to go into the sequence app. And in here, we're going to put in, to get the next term, we need to get 1.03 and multiply this by the previous term. In this case, it's a of n because we're using the calculator. When you press execute, it's going to say, yep, this is approved it. We're going to tick. We now need to know what our initial amount is. This is 18,000. Now that we've got that, we want to see how long it will take for this 18,000 to go past 25,000. So when you set your values up, your starting value will be 0. The ending value, we can put technically any amount that's relatively high. We're not going to go from 0 to 1 because that's not going to give us enough information. So maybe as a good starting point, we can go 0 to 50. Press OK, and clicking this button here will get your table of values up. We'll resize this and we'll look for when it hits over 25,000. So at year 11, we're at 24916, and then at year 12, we're at 25663. So it is on or within the 12th year that the investment first exceeds 25,000. So within the 12th year, it's not here, as K of 12 is equal to, and you'll just put that amount that is in there, 25664. We'll round it, yeah, we'll just put it as 25664. 25664. Now I say within the 12th year, you could technically say at the end of the 12th year as well, because we have no idea when it reaches 25000. We know it reaches 25664 at the end, at least at the end of the 12th year. So I always say just within the 12th year. Now question 7 says, using the recurrence relation from question 6 that we have here, we're going to write a rule to get the nth term. So remember, a rule and a recurrence relation are two different things. Recurrence relation always tells you what the initial is and then how to get the next term. Where a rule will say, well, give me what iteration you want and I can tell you what the answer is without relying on the previous terms. I can go straight to any term you want. So when it comes to a geometric growth of some sort, to get the term, we have to get the rule, sorry, you have to find what the R value is from the recurrence relation. And all you simply do is put the n as a power. And this will be multiplied by what your initial is, 18,000. And all this is saying here is, all right, if I want to know what the value of this investment is after maybe 60 years, all I'll need to do is work out what 1.03 to the power of 60 is and multiply this by the initial amount, 18,000. You don't have to rely on what the 59th is, or the 58th, or the 57th, etc. The last question here says the first 4 terms in a sequence using the recurrence relation m of 0 is equal to 1, and m of n plus 1 is equal to 4 times m of n plus a. Gosh, another tongue twister. Again, with this type of question, you would just use your calculator to solve this. Let's resize this back again. And we're literally just going to put in the recurrence relation that has been stated there. So this would be 4 times a of n plus 8 with an initial value of 1. Now it's just only asking for the first 4 terms, so we can go from 0 to 4. It really doesn't matter of changing the input from the previous one, but just in case. Alright, so the first 4 terms, technically, the first 4 terms includes the initial one. We should have just gone from 0 to 3. So our first term, m of 0 is equal to 1, m of 1 is equal to 12, m of 2 is equal to 56, and m of 3 is equal to 232. So our first 4 terms within the sequence, 1, 12, 56, and 232. And that concludes this video. If you need to do the other outcomes for number patterns and sequences, check out the other videos. Until then, catch you guys soon. Bye-bye.